Hi everyone, our group has implemented a data analysis and visualization project based on the PlayerUnknown Battlegrounds game. Our presentation mainly focuses on two aspects, dataset and functions we implemented based on the dataset. PUBG is a popular survival sandbox game, and the only winner of each game will be the last survivor. Each data in our dataset is in the JSON format. This is an example of what we call telemetry data, and the telemetry data is an array of important events happening in a match. Each event has the /t attribute to indicate the event type, /d attribute to indicate the event time, and other attributes describing the event. The dataset is collected from the PUBG official developer API, which requires us to request certain format URL to get the information with a rate limit 10 per minute. The total size of the dataset is 55 gigabytes. The dataset contains general information of 30,000 matches and detailed information of 5,000 matches, along with some side information about the player and game seasons and so on. So the first function we implemented is the death or weapon and medicine heat maps on different kind of maps. The data we use in this function is extracted from the telemetry data. We run through each event of the telemetry data, extract atom, player name, and locations, separate them by the map name, and stores them in the CSV files. The two events we used in this function are log player kill and log atom pickup. In each event, we get the atom player names and locations according to its structure. We first divide the x and y axis of the map into 800 small segments. For the death heat map, we simply calculate the death frequency of each grade. For the weapon and medicine heat map, we give large weights to the rare weapons like AWM or rare medicines like medicine kit, and calculate the weighted frequency of each grade. Second, because of the school distribution of frequency on the map, we clip the frequency to a certain range and normalize it. At last, we transform the frequency map into a colored map using the built-in color map. Adjust the alpha channel of the heat map and stack the figure on the background figure of the actual game map. So this is the background picture and the death heat map of Erangel map. This is the background picture and the death heat map of Miramar map. This is the background picture and the death map of the Savage map. And this is the weapon and medicine heat map of Savage map. We randomly select 10% of the raw telemetry data to generate the heat map, and we can see it compared to the original heat map. The data is distributed uniformly across the dataset. We can see from the heat map that each map has some certain cities have higher death rate. Those cities with high death rates are usually in the center of the maps, because in each game the plane will drop players by a straight line, but those cities will stay close to the straight line. there are high chances that there are more people in those cities than other places. But the weapon and medicine heat map shows that there are almost uniform distributions on those resources. The suggestion we give based on the heat map to those rookie players is to avoid cities with high death rates because other resources can be collected from other cities. So now let's talk about the rankings prediction. PUBG is all about surviving, therefore it's very important to study how to prolong the survival time. We use the data containing 1 million players' information for analysis. So first step is to do data pre-processing. We extracted players' statistics from match data, and this is our extracting code. 3 regression model is used. Linear regression model has the best fit, the average prediction error of which is 3.97. So we decided to use this model to do strategy analysis. A feature with a positive linear coefficient will cause the ranking to drop. Based on linear model coefficients, we found some extremely interesting phenomena. So understandably, both healing and acquiring weapons will rise the ranking. However, based on our statistic, if the player kill one enemy, his ranking will actually drop by 0.7. If the player only damage but not kill the enemy, his ranking will rise by 0.5. Consequently, we came up with 3 dark rules of surviving based on our regression analysis. First, damage your enemies, but do not try to kill them. Second, never stop collecting drugs and never stop collecting medicine and weapons. And I believe this advice would be very practical for millions of players. Okay, so next part is dynamic visualization. We're going to do visualize dynamically the process of the match. First of all, we extracted coordinates of players' real-time positions and the coordinates of blue zones and the safe zones position. Here, blue zone is a circular area on the map, outside of which there will be poisonous gas, which is harmful to players. Safe zone is a specific area within blue zone, to which blue zone will consistently approach. Specifically speaking, we extracted players' ID, locations, health condition, and corresponding timestamp from logs of player position. We extracted zones coordinates and radiuses from logs of game state periodic. In this demonstrating figure, players are presented by small circles. Colors of those circles correspond to player's health condition at that time. If a player is 100% healthy, the circle will be in white color. If he is dead, the color will turn red. And if he is attacked and hurt, the color will gradually transit from white to red. Blue zone will be presented by a blue circle, while safe zone will be presented by a white circle. Now, in this demonstrating video, you can see that at the very beginning, players are moving in a straight line. That's because they're on an airplane flying to the destination. When they drop off the airplane and land on the map, they scatter around. You can notice that the majority of players lands in cities or towns on the map. That's because important weapons and medicines are distributed in those spots. As time goes by, some white dots already turn red. That's because some players have been killed in battlefields. When blue zone appears, it gradually approaches toward the safe zone. As soon as it touches the boundary of safe zone will immediately shrink to a smaller one within the new blue zone. Meanwhile, you can see that players are moving towards safe zone in order to escape from the approaching poisonous gas. You can see that if some players fail to catch up with the blue zone, they will turn pink or dark red because they are exposed to the gas and are poisoned. At last, there will be only one white dot on the map, which is the last winner. Thank you very much.